Hi there, welcome to a second lesson on exponential graphs. In the previous lesson we just looked at the introduction of exponential graphs, but this kind of takes it that little bit further in looking at a problem involving exponential graphs. Okay, so let's kind of dig straight into it. So sometimes you might be able to find an equation of an exponential graph by substituting in coordinates. Okay, all right. So I'm just going to kind of recap briefly what the exponential graph equation looks like. All right, so please look at our previous version, but it takes the format of y equals ka to the x. All right, we can see from our graph that it's an exponential graph. It kind of grows and grows and grows and grows, and it's these values that I'm after. All right, so like any equation of any graph at any time, it normally has a y and an x. All right, so I've got a y there and I've got an x there, and it's these two variables that I am after. All right, and using the two coordinates that I've currently got given, that should allow me simultaneously to provide me with the values of k and a. All right, so I'm going to start off with the one which is normally the easiest one to work with, and that's this one over here. All right, you've got an x value which is 0 and a y value which is 2. All right, so those two numbers there we're going to put into here. Okay, so like it says, let's first substitute the coordinates into the equation. So for 0, 2, so y is 2, so let's have a look. So y is 2, and then ka to the 0, so ka to the 0. All right, well, this is the rule of indices, which I mentioned in the previous video, which if not looked, please do look at. Anything to the power 0 is 1, so that would be just k times 1, which is effectively just 2, isn't it? So so k is therefore 2. Well, one of them done, already kind of figured that one out. So I've got k as 2 already. All right, so that's my first bit. I've got k. The next bit is I need to figure out what a is. All right, so in terms of obviously trying to think about what my scenario is that I've got a value of 2, and then that value of 2 grows exponentially. All right, and how it grows exponentially is based on this multiple here, this multiple of a to whatever power, and that's what I need to try and figure out next. So we're going to now put the new coordinate, the 3 and the 54, and our newfound friend k as 2 into this to figure out this, because I've got a y, an x from the coordinate, and the k, which should leave us with the value for a. All right, so for 3, 54, let's put them all in there. So y is 54, you've got k and then a cubed, so I've just put that in. But we know now that k is 2 from the previous one, so we now have this formula here. So 54 equals 2 times a cubed. So because we're doing rearranging a formula, effectively I'm going to divide by the 2, which is going to give me a cubed equals 27. And then now what we need to do is cube root it. So with our calculator, or in our heads, and we might be able to do it without it, what is the cube root of this particular number? Well, this is a cube number, fortunately, so it's quite straightforward. So a is going to be 3. All right, 3. All right, so that is the two values that I'm after. But have I answered the question at all? Calculate the values of a and k. Yes, I have. All right, it doesn't ask me to put it back into a form or anything like that. They are my two values, so that's that done. All right, so relatively straightforward. This is actually more about substituting numbers into a formula to figure out unknowns, isn't it, really? The only thing that you need to know before starting this is what this equation should look like. All right, so this is where the previous lesson, when I talked about exponential graphs and knowing that kind of equation, you need to know that an exponential graph takes this format, and therefore you need to know that these two numbers need to be substituted into it in order to find those two values there. All right,